Today you're going to distinguish between linear functions, quadratic functions, and exponential functions. Okay? To tell if something is linear, let's say I had a table of values, x and y, and I had x is 1, 2, 3, 4, 5. Linear is a straight line. If we graph it, and then I had the points 1, 2, 3, 4, 5. So as x goes up by 1, then the y values go up by the same amount every time. So this might be 4 and 4.5, 5, 5.5, 6, and so on. So to check to see if it's linear, you look at the x's, plus 1, plus 1, plus 1, plus 1, and then you look at the y's, plus 0.5, plus 0.5, and that pattern continues. Okay, a linear function is one that goes up by a constant. It's the same change every time. It's the same addition every time. Plus 1/2, plus 1/2, plus 1/2, and so on. Okay, we could have this. What is the linear change in this function? Minus 5. So the x's go up by 1, and the y's go down by 5. So the slope would be negative 5 over 1. Down 5 over 1, down 5 over 1, down 5 over 1. And that would be a linear function. Okay? So the way to tell if something is linear is we make a column over here. We call this column the first difference. And then we take 10 and subtract 15, and we get negative 5. 5 subtract 10, negative 5, negative 5, negative 5. If that column is made up of the same numbers, then it is linear. Oops. Is this linear? If I make my column of first differences, what's the difference between the second one and the first one? I added 1. Plus 1, the next one. Plus 2, the next one. Plus 3, and the next one. Plus 4. So my first differences are not constant, which means it's not linear. Well, it's really easy to tell if something is quadratic, if it's the shape of a parabola. You calculate the first differences, and then you calculate what we call the second differences. How much do the first differences change? So if I add another column right here, how does the first difference differ from the second one? Plus 1, plus 1, plus 1, and so on. If this list is made up of the same number, then it's an x squared equation. So if these match, it's an x to the first equation. If these match, it's an x squared equation. And if you needed to, you could go down to third difference, and if they're the same, then that is x to the third, and so on. So an x to the fourth would have a constant fourth difference, and so on. Okay, so that takes care of linear and exponential. The only other function we're going to deal, linear and quadratic. The only other function we're going to deal with is an exponential function. And an exponential function does not have constant differences. it has something else. It would be something like this. Okay. We can test the first differences. What are the first differences? 1, 2, 4, 8, 16, and 32. Is that linear? No, so let's calculate the second differences. 1, 2, 4, 8, 16. Should I calculate the third difference? How come? It's never changing. It's the same list over and over and over. So this is not linear, and it's pretty obvious it's not going to be x squared or x to the third or x to the fourth or something larger. So we need to find a different pattern. Do you see a pattern in the y's? Multiply by 2. So this would be times 2, times 2, times 2, and so on. If the pattern is multiplied by the same number, then it's called an exponential equation. So if you add the same number every time or subtract the same number every time, that's linear. If the the second differences are constant, then it's quadratic. But if the differences are never going to work, and you check multiplication, and you see that it's multiplied by the same number every time, that's an exponential equation. Okay, let's look at this. Do you see a pattern there? It's what? Dividing by 2. That's the pattern. But when we use exponential equations, we never talk about dividing. We always talk about multiplication. Can I find a multiplication pattern? Times 1/2. So 200 times 1/2 times 1/2 times 1/2, and that pattern continues all the way down. So that would be an exponential equation. Does that make sense? Okay. Let's look in your book. I'm going to look on page I'm on page 171. (171A). Now this table of values is horizontal, but that's okay. Look at the x values. Excuse me. -3, -2, -1, 0, 1. So the x's are going up by 1. Do you see a pattern in the y's? -3, -3. If I check 2 of them, is that enough? No. You have to check all of them to make sure that it's truly linear, because if one of them doesn't work, then it won't be linear. -3 and -3. So this is a linear equation. Okay? Do you see a pattern in B? What's the pattern? So if we try the addition, I get plus 1, plus 2, plus 4, plus 8. And then if I did the second differences, plus 1, plus 2, plus 4, it's pretty obvious that's not going to work. So now we try multiplication. Times 2, times 2, times 2, times 2, and that's it. Multiply by 2. So this is what type of equation? Exponential. All right, letter C. How do we get from negative 1 to negative 2? Subtract 1. How do we get from negative 2 to negative 1? Add 1. How do we get from negative 1 to 2? Add 3. And how do we get from 2 to 7? Add 5. Do you see a pattern there? Not yet. So it's not linear. Let's check exponential. How do you get from negative 1 to negative 2 using multiplication? You would multiply by 2. How do you get from negative 2 to negative 1 using multiplication? Times by 1/2. So can this be exponential? The first one was times 2 and the second one was times 1/2. So no. Well, what should we try? We need to check to see if it's quadratic, so we do the second differences. How do you get from negative 1 to 1? Plus 2. How do you get from 1 to 3? Plus 2. And from 3 to 5? Plus 2. The second differences are constant, which means this is a quadratic equation. Okay, does that make sense? All right. Let's go down to this box here. Do you see a pattern? What is it? Multiply by 3. Times 3, times 3, times 3, times 3. So this one is exponential. Okay, turn the page. Okay. Is this exponential? 12 times what is 0? 0. And 0 times what is negative 4? There is no number that works. So this can't be exponential. Let's check to see if it's linear. How do we get from 12 to 0? Subtract 12. And how do we get from 0 to negative 4? Subtract 4. And how do we get from negative 4 to 0? Add 4. And how do we get from 0 to 12? Add 12. Now this is obviously not linear. Let's check to see if it's quadratic by doing the second differences. How do you get from negative 12 to negative 4? Add 8. And from negative 4 to 4? Add 8. And from 4 to 12? Add 8. So this one is quadratic. Good. All right. Oh, shoot. Let's go. So I found out that this one is quadratic. How do I figure out the equation? I know what type of equation it is. How do I find the equation? Well, we'll just ask our calculator to tell us. right? If I wanted to create a straight line, how many points do I need to figure out a straight line? So if I had 1 point, is that enough to tell me which? No. But if you had 2 points, how many lines are there that go through 2 points? Just one. Okay? Same with an exponential equation. If you want to find an exponential equation, you need 2 points. But for a quadratic, so if I'm graphing a parabola and I know it hits here and here, how many parabolas are there that go through those 2 points? An infinite amount. It could be this parabola, it could be this parabola, it could be this parabola. There are a whole bunch of them. So as soon as I pick a third point, now I know which parabola I'm dealing with. So once you decide which equation you're dealing with, you need to put points in your calculator and ask it to do a linear or quadratic or exponential regression. And if you are dealing with a linear or an exponential equation, you just need 2 points. If you're dealing with a quadratic equation, you need 3. So, go into Stat. We've done this before, right? Stat, Edit. And then clear out your L1 and your L2. Don't push Delete. Push Clear. Which 3 points should I pick? And the answer is, it doesn't matter. As long as you keep your X's and your Y's matched, it doesn't matter which 3 points you pick. So for X's, I'll do 0 and 1 and 2. And for Y values, 12 and 0 and -4. Now where do I find the regression lines? Go back into Stat. And over to Calc. Which one should I do? Number 5, quadratic regression. And I get 4x squared minus 16x plus 12. Anybody have trouble with that? No? Okay. So this is at the bottom of that page. We need to figure out if that top one is linear, quadratic, or exponential. And once we figure out which type it is, we need to calculate the equation. Do you see a pattern in the y's? Times by 1/2. So this is times 0.5 times 0.5, and it works all the way to the end. So how many points do I need to create an exponential equation? Just 2. Go back into Stat and to Edit. And the Y values will be 16 and 8. And the X values will be -1 and 0. And Stat, Calc, which one should I choose? You can't actually see it. You've got to go down, or I'm actually going to go up. It's faster. It's number 0. And then calculate. How do you write that equation? 8 times 0.5 to the x. 8, and I would probably do 1/2. You could do 1/2 to the x, or you could do 8 times 0.5 to the x. Okay? All right, the next one. How do you get from -8 to -1? Add 7. And from -1 to 10, add 11. From 10 to 25, 15, and from 25 to 44, 19. Is this linear? Nope, first differences don't match. Is it exponential? How do you get from -8 to 1? -1. You would times by 1 over 8. How do you get from -1 to 10? You would multiply by -10, which is a different number, so that doesn't work. Okay. Let's check to see if it's quadratic by finding the second differences. How do you get from 7 to 11? Plus 4, and from 11 to 15? Plus 4, and 15 to 19? Plus 4. This is quadratic. How many points do you need to create a quadratic equation? 3. What if you only plug in 2? What's going to happen? You're going to get an error. Your calculator will freak out and say it can't be done. Okay. 0, 1, and 2. And -8, -1, and 10. Stat, calc, and quadratic regression. And the equation is 2x squared plus 5x minus 8. Easy enough, right? We don't want to do average rates of change. I don't want to do recursive either. So in 3.7, we're going to finish the set. And we are going to do 15 through look at number 25. How are you going to figure out number 25? What should you do to find the equation? You need to create your own table. You have the points. You need to put those points into a table. And 25 is obviously quadratic, and 26 is obviously linear, but you need to plug those numbers into your stat to figure out what the equations are. 27 and 28 say find the function represented by the table of values and write it in as a recursive rule. We're not going to do recursive, so just do 27 and 28 like you will all of the other problems, but the answers in the book won't be the same because a recursive equation is a little bit different, but we're not going to talk about that. Okay, 29 and 30 you can do. 31 you can do. Do they not do average rates of change? I want you to go all the way. Okay, we don't want to do 34 or 35 or 33. So we're going to do 15 to 32 all. And then 38 is the last one. This is not a new assignment. This is attached to yesterday's assignment. All right? Okay, get to work. Sylvia.